fortunate indeed to be involved in the science, the technology, the manufacture, and the use of this beautiful natural product that we call leather. What other material has been involved in the development of mankind at most stages of the last 2 million years? At its best, leather is both aesthetic and functional, and can be sold with a reassurance, if cared for, it will mature and improve with age, just like men. I can be as sexist as anyone. In context, it is a truly classless material with users from the elite to the precariat, from make-do and mend to the white heat of technology. But such optimism is not always reflected in the global leather industry, with a product offering that, without being too critical, has increasingly become out of touch with modern consciousness. 65% of people under 30 in the UK do not know where leather comes from. More frighteningly, neither do they have a view on its position in the appropriate perceived value analysis of any product. I mean, look at Reg. Where's Reg? Look at Reg. Look at Reg's YouTube video.
Oh, yeah.
Anybody he sits next to on the plane doesn't know anything about the leather industry.
I'm glad you watched it, Pete.
And that includes Daniel Craig. And he was on the film. If the industry has a significant future, it has got to be profitable. To make a small fortune in the leather industry today, you have to start with a big one. The global leather industry apparently produces 20 billion square feet of leather annually, raising 40 billion US dollars. These are not my figures, I got them from the internet. Simply, that's an average selling price of $2 US per square foot, not an encouraging financial analysis. But I can tell you why this is. In the language of the tannery floor, it's because at least 75% of the 20 billion square feet of leather that we produce today is commodity crap. It's because at least 70% of what we produce goes to effluent. Every one hide we produce approximately gives 70 to 80 square feet of saleable leather, throwing away at least a quarter of the collagen available. And more controversially, it's because our quality control and innovation are at least 20 years out of date. Without profit, the industry cannot invest in real innovation, environmental improvements, brand enhancement, or new markets. We all know in these areas there is a significant possibility of improvement that we could all make if there was the money there to do it. Must we always be at the mercy of the financial uncertainty of being the recycling arm of the food industry? What I would like to present today is a little hope, a very small amount of hope, a small flickering light at the end of this tunnel of uncertainty. Leather manufacture must develop in a sustainable, way which is appropriate to the digitally interconnected world that we live in. Proven and developing technologies must be used that supplement and complement the natural beauty of leather. The subject today is the functional surface decoration of leather, the way that it is expressed. The most significant word is the word surface, that top 10 microns. If you think about it in terms of leather, in terms of every product that we make, what do people see the first of all? What do the people touch first of all? And that's that top 10 microns of leather. And we must have a way of responding to almost the natural, the primeval responses of that top 10 microns and their colour and their pattern and their touch. In less emotional terms, the balance between the aesthetics and the functional determines the specification of leather required. And the specification obviously must be appropriate to the markets that we are entering. These top 10 microns have been decorated or supplemented for almost as long as leather has been around. Here in Fig 1, 35,000 years ago, this is decorated leather with skin clothing. And note, even then, the despicable use of size 0 models. 150 years ago, with the advance of machinery, surface decoration was mechanized and semi-automated, with 85% of the global leather being produced now is produced by spraying and curtain coating and roller coating techniques. Over the last 40 years, systems have been developed that have obviously enhanced, and I'd never want to decry the work that's been done over the last 100 years or the last 50 years. There's been tremendous work done on enhancing fault cover, on giving high performance or mimicking the feel of aniline leather. Tremendous work done in that area. But today we want to concentrate on the use of another type of technology, digital technology, that can control and enhance the decoration that has been given over the last 60 years. Our technical objectives have been to increase the physical properties of any leather or any competition material, and you just have to question how leather has actually lost market share in many areas. It's because it has lost it on property grounds, as well as being easier to cut. Many of the synthetic materials that are available today have properties that are in advance of leather. So we must get that market ground back. What we want to do is to inspire by digital technology the modern fashion and graphic designers worldwide to help take leather into the 21st and the 22nd centuries. Now this requires automated jet control of the spraying systems that we already use. And it means delivering performance by combining the properties of leather with other technologies. These technologies are capable of giving consistent performance properties outside the normal confines of collagen science. I do not, again, having been in the industry for 50-odd years, criticize any of the technical work that has been done and any of the development work of trying to alter the collagen structure by adding chemicals to it. That it is wonderful, but it is sometimes an imprecise science, as I will go on to describe. What I want to put forward is a new technology, which is membrane technology, where one is combining membranes with the surface of natural leather. But before doing that, I want to describe the spray systems that are actually used to put surface decoration onto the membrane that I'm going to describe. Any type of spray system can be adapted to be digitally controlled. The precision control of spray jets by digital technology has been possible for approximately 20 years. Digital spraying assembles each sheet of colour or image from a complex set of numbers and mathematical formulae. These images are captured from a matrix of dots called pixels using process digitalization. The digitalized information is used to control the deposition of ink or pigment or direct electrical energy to reproduce the data. A color management system is used to ensure from the color that you see on the computer screen to the color that appears on the leather. The management system is virtually instantaneous and can work with thousands of miles distance in between the control computer and the spray head. The advantages of digital surface decoration or using this sort of system are many and several. What you can concentrate on is the leather. It's spraying onto a rationalized eco-base leather. The base material that can be used can be designed, and all effort and research effort can be made to make that eco-base leather consistent and rationalized, and it can be the base of the future of the leather industry. The second is designing the process that can be applied to the top 10 microns of leather can have an ecological design, if that is what is wanted by the world, or it can have a design that is available to whatever market one wants to enter. The capability of meeting performance specifications can be done consistently. Consistency with regard to leather performance in the world is a big debate. We never do enough testing, really, to establish the consistency of the product that we make. But if it is done digitally, I want to forward a way where it is possible to guarantee that time after time. Rapid prototyping and fulfillment of design, incredibly important in today's modern world. How one gets from the design board into production is of the essence in terms of replacing old products, of replacing products that are already there and need more production to them. The prototyping and how that is done is incredibly important. And it brings back to this way of how you can manufacture from a small scale to a bulk scale across a global market. There is a concept in California of personal manufacturing, where people are genuinely manufacturing things themselves in quite advanced market areas. At the present moment, it's only an incredibly small market area, but it's building. And in terms of the world that we're involved in, you'll find that at least 10% of people are interested in making things themselves now. They're getting a little skeptical about getting things that fly across the world in several times before they're manufactured. That will always go on because we're in a global world. But if you can get a way of producing leather that can be both personal and it can be bulk manufacturing, then I would advocate that that is the way for the future. Stock reduction and stock replacement, just-in-time delivery systems, the use of instant digital information enabling personalization and mass customization, very important with regard to the world that we've been in for 20 years, but we are going to increasingly enter. As these techniques become increasingly more financially viable, people will love to have an input into the products that they actually make. And if we can give them manufacturing methods that give them that input, and they are available now, it will be a wonderful position for the leather industry to take. I can tell you of at least 10 companies in the UK that are making leather products by putting individuals' designs that they've sent over the internet, and they come into quite an advanced computer system, and then it's put into digital information, and overnight, on a 24-hour delivery, the bag that they've chosen for their particular design or their particular photo to be part of is dispatched to them. That, to me, although in one way it sounds incredibly mind-boggling because of, you know, the history, my history and where I've come from, but to me that's the future, because people are living in an increasingly personal world where they want to contribute. And that will eventually get to the way that they are manufacturing locally, and you have a system where what we do is involved in a much more sustainable world than we've got now. What I would just like to do is talk about the technology that could make that possible. Now, with all new technology, with the sustainability argument and with digital strain, there are bound to be different methods that evolve. And these are 7 of the different methods that are available now in the UK, used by companies now to produce leather products. Direct spraying of acid dyes. Paul Smith, God bless him, multi-millionaire, very large part of the Japanese market. He's using spraying direct acid dyes onto leather to make the products that he uses. And all of these are possible ways of making what I'm calling the digital revolution to occur. Each has its own strength for the decoration of leather surfaces at different levels, at a craft level or an industrialization level. In this paper, we would like to concentrate on one of these methods that we will advocate and we believe is the most flexible and the most capable of mass industrialization and development, but more importantly, has the capability of significantly enhancing the profitability of the leather industry. And this is what I call membrane technology. Membrane technology involves fusing a micro-thin membrane into the grain or layer surface of a tanned leather hide. A layer surface is one or both of the surfaces of a leather split taken from the hide. And I would ask you to reserve judgment with regard to the word split, because we in the leather industry have been fortunate enough to be given full thickness hides, and I advocate it is our, not our duty, but our way of going forward that we maximise the whole of that hide and not just a thin surface of it. There are two key features in this. One are the properties of the micromembrane technology, and the second is stratigraphic economics of how one uses a hide. Firstly, the micromembrane technology. There are several teams of polymer science workers around the world working on different building blocks for making membranes or skin membranes. And these include synthetic collagen, as I'm sure a lot of you know. Our choice has been a polyurethane memory polymer, which is outlined in a website, www.hbpolymer.com, and all of this talk is available on our website, and you can download it if that is your wish. The reasons for this choice of polyurethane memory polymer was because of the potential of the urethane molecule. So far we have commercialized it as a 7-micron cast membrane, which permanently accepts a colored layer of approximately 2 to 3 microns. Most special are its memory polymer characteristics at around 180 degrees centigrade and 100 psi, which enable it to bond ionically and irrevocably to either other specific polymers or to complexes within the structure of the collagen matrix. The micromembrane is colored on its dye-reactive side. The dye molecules react instantaneously and precisely where they are deposited. The eco-solvent evaporates, leaving a layer of organized color. Where necessary, this colored layer is mirrored because it faces down onto the leather. The catalyzed ionic reaction takes place through this sheet of color, securing it as a permanent part of the leather. At 180 degrees, an ionic exchange takes place between the membrane through the catalytic ink layer into the ion receptive leather layer, securing the membrane into the collagen matrix. The physics of this adhesion can be established and has been by 3 recent developments. It's the use of something that I didn't know existed 2 years ago, atomic force microscopy. And I'm sure that atomic force microscopy? Yes, yeah. Amanda knows that. But it allows on a fine scale the measurement of adhesive points of contact. The second is the large-scale computational material science, which permits the hierarchical studies of interatomic potential of billions of atoms. And it is understanding what is actually happening in the surface, those top 10 microns of leather, and how they react, and how they can be controlled in a reaction process with, in inverted commas, membrane technology is the vital process. The third is the push in the microelectronics industry towards nanoscale. You read what's going on in microelectronics and it's absolutely phenomenal. It's got to, because there's billions of dollars of investment going into that industry. But it's a push on a nanoscale that we can take advantage of. We can cross technology. We have to have it reflected in our industry. So the engineering of these membranes can be done on a very market-centered approach. The membrane can be engineered in two very significant ways. It's combining materials within the membrane, i.e. the addition of nanocarbon tubes to the membrane which give it phenomenal strength, or it's combining different multi-performance membranes by microlamination. A foundation white membrane can be used to give absolute color matching. Equally, within the membrane, technology is available to engineer strength, reactivity, surface friction, abrasion resistance, conductivity, water vapor permeability, waterproofness, feel. The list is endless. Let's just consider one of them, the one that I understand the best, leather feel. A perennial discussion in between leather buyer and leather sellers the world over. It's quite a long time ago that I met Freud's grandson, but he told me the main endeavor when you're making a piece of leather for deep psychological reasons was to recreate the feel of human skin. Like a woman's thigh has been the holy grail of finishers the world over. And like a man's thigh has been the holy grail of other types of finishers the world over. When anyone judges a piece of leather by touch, there are thousands of electrical messages sent to the brain from the cutaneous and subcutaneous receptors in our skin. It sounds a little advanced, but understanding what happens there is really of considerable significance if we really want to make this judgment about the feel of leather. And again, on the website, there's the background with regard to the science involved in that. Recreating these touch characteristics have been a primacy in membrane development. What has been achieved is a membrane that disappears into the surface of the leather in all but the surface color that is left. It takes the properties of the leather underneath. A little more technically, the strength of the membrane can be increased to unimaginable values. Human beings are now photographing galaxies over 10 billion light years away. 10 billion light years, and the photographs on the internet. So why should it be so hard to believe a 0.5 millimeter leather split can be given the strength of a 2 millimeter shoe leather? That is possible now. And what's more, engineering a membrane is simpler and more consistent, and best of all, more flexible than engineering leather. With leather guaranteeing new molecules are going to deposit appropriately every cubic centimeter of collagen is like exploring the universe. And like David Bowie, over the last 50 years, I've been around that a lot. But there are difficulties involved in leather technology and constantly giving it renewable properties. I guess what I'm advocating is combining the the best of leather, the most naturalness of leather, with other ways of getting performance properties into it. The research efforts with leather needs to be focused towards consistently, towards consistency, towards carbon footprint and targeted base leather properties. If we do that, we can have a product that will be part of the next 50 years, a leather that can be produced consistently. And we all know the heartache in doing that, but we all try and do it with 10,000 different properties. You know, show me a tannery that hasn't gone and expanded its product range 100-fold. And it's all for the good intent of getting performance properties out of that material. But by combining technologies, there's every possibility that if you produce leather as consistently as the 21st and 22nd century will require, the other technologies can be actually used to enhance the way that we enter all the markets that we do. Just taking to end the type of products that, type of properties that we can engineer of specific interest is the particularly water vapor permeability, because you think when you put a film or a layer onto leather, it's going to take away its water vapor permeability or its air permeability. With what we have, when you get down to areas of 3 to 10 microns with any type of membrane, they all have water vapor permeability. And they all have air permeability. At Aircraft Interiors Expo 2013, there was significant interest in the premium and business class seating area. The advent of synthetic meshes for weight and air transmission should not be ignored by the leather industry. There has been a dignified research program on the dispersion of flatulence through seating materials. This is not a lie. The New Zealand University, you can look it up. Apparently one farts more at 35,000 feet than one does at ground level. And what's worse, the odour lingers more in first class because of the use of pigmented leather over the last 20 years. What more precise, more targeted argument can I put forward for membrane technology? Now, so those are the sort of properties you can engineer within the membrane itself. Combining the membrane, you can combine different membranes. It's possible to layer at least 50 of the membranes that I'm talking about and still be within the definition of leather. 2 membranes are recommended, and it's only then, only when necessary. The second foundation membrane can establish a base colour for the leather, or performance-wise it can give a diametrically opposed property to the membrane that goes on top. Why leather at all? Consider these 2 jackets. Will Amanda model them? If you want. Do you mind taking it? Where's, sorry, where's it? I'm so sorry. This wasn't. Now that's a beautiful No, it is wonderful. It's a wonderful, soft, sensuous material. It has the feel. Yeah, to, you know, UK leather expert. Wonderful material. Yeah, no problem at all. No, well, no, not until you try this one on. Now this, another beautiful jacket. Again, a little bigger, but equally as beautiful and small. They're really quite nice. They're nice materials. They're nice jackets. As Christine doesn't think it's leather. It's not leather, is it? No. It's not leather. Now, these are the two most informed ladies in the whole of the leather industry. Polyester leather. Now, that's not meant, I couldn't tell, I bought them from bloody fashion. Oldstown, I think it was, I didn't tell the difference. I paid £5 for one of those. But in terms of principle, there are very few of us can actually tell the difference in terms of certain types of leather these days. They can't. They have great, how do you tell the difference? People don't tell you it's leather in the shop. They sell you a polyester jacket. They don't say it's not leather. They don't say it's polyester, but people make assumptions. People make assumptions. So we live in a very turbulent world with regard to leather. But what can we do about that? One is to realise that we are in a very competitive industry where we have got to make the most of the raw material that we've got, and we've got to push the characteristics of leather and make them as available to the world as we possibly can. And I know there's some wonderful attempts that Mike's doing with leather naturally, and lots of people are involved in to push those positive characteristics of leather. But from the point of view of the raw material that we're given, we've got to be as creative as we possibly can. And this comes down to a way where we can revolutionise the profitability of our industry. Out of these 60 or 70 square feet of leather that we sell from each hide, it's pitiful that we actually throw away collagen. Out of a 7-8 millimeter hide, we can get 1, 2, 3, 4, 5, 6, 7 layers. And you can't tear them. This is without membranes. But if you had membranes, it makes it even more certain. 7 layers out of a hide. And at the present moment, at the best we get 2. Ladies and gentlemen, I just want to rest my case that we can use the raw material that we get, if we consider it stratigraphically and creatively, we can get a profitable industry ahead. I just want to finish on, oh, God, whoa, you wouldn't believe this. If there is anybody who wants a beautiful mouse mat, you see, even mouse mats are going vintage these days. But vintage is in, so it doesn't matter. And so there you are. We've produced a few at this present moment. We'll produce more during the next 30 minutes. If there is anybody who wants one of these sent, doesn't get one today, please email us and we'll be absolutely delighted to send you one free of charge. I'm sorry, the lecture is far too much in predominance at the beginning of it, but they, excellent sir, for your contribution to the world leather industry. Can I present
Thank you, Peter. You've had your time.
Sorry.
Round of applause for Peter. I'm sorry, I didn't realise you'd gone so far over. So there are no questions. If you've got any questions, buy him a pint and he'll give you a free rat to stop to your mess. Right, come on,